Hello again, everybody, and welcome to another Geo-Institute live stream. Today is day 9 of Geopalooza, the extravaganza of content that we bring you every single May. If you want to go back and look at what we've brought you in previous days, I would actually encourage you to do that. Gems such as Geo Legends interview with Syracuse University's Shobha Bhatia. There was a director's cut last week with Menard's Jorge Fuentes. We have had videos, we have had blogs. You can check it out all on our YouTube channel or at geo-institute.org. My name is Brad Keeler. I'm the director of the Geo-Institute. And again, we're really happy to have you with us for our live stream today, which is episode number 5 in the illustrious series that is Hour of Scour. If you don't know anything about the Geo-Institute, after you watch this interview today, you should head over to geo-institute.org, and there you will find out so many things about us, including that we are a technical society with about 12,000 members, most of whom are geotechnical engineers and or geologists, and that we are part of the American Society of Civil Engineers. And if you like what you see today, and no one, literally no one, has ever watched an episode of Hour of Scour and left not liking what they saw that day, you should click like, subscribe, get notifications, and we'll let you know every time we post something to the YouTube channel. We are thrilled to be with you today for Hour of Scour to talk about something new that we haven't focused on the show yet, and that is wind scour. This episode came about when we were at Geo-Congress 2026. I was very loudly telling someone about Hour of Scour, and I said, we haven't had an episode on wind scour yet. And the esteemed professor, Dr. Brina Montoya, the NC State University, said, wait a minute. We have somebody doing wind scour research, and here we are. And here to tell you a little bit more about it is the host of Hour of Scour, all the way from San Marcos, Texas, where she's a faculty member at Texas State University, Stacy Kalasia. Scour and erosion expert. Can I throw that in? How about that?
I'm claiming it. I mean, this is basically my rise to claim. Don't worry about publications, don't worry about research, but being the host of a world famous podcast. I don't know if my boss is watching, but I have implied that this podcast is because of my world fame.
1.5 billion viewers every week.
Wow. Yeah.
Sorry.
Yeah. So I'm Stacy Kalasia. I'm an associate professor at Texas State University. I do research on scour. I am the director of the Create University Transportation Center, which is a coastal infrastructure durability center sponsored by the US DOT. And we also do a lot of scour research within our center, both off the coast and for your inland infrastructure. And I would like to point out that Hour of Scour came about from the great mind of Brad and me being a little silly. And he said, let's do it and do 4 episodes. You can commit to 4. And I said, fine, I'll do 4. It'll be fun. And then next thing I know, Brad's like, episode 5, here we come. And I was like, no. You said 4. And he was like, oh, but wind scour. We could keep going. And so I am excited with that to introduce our guest of the day, Paula, a PhD, I didn't ask, candidate student at NC State.
I'm a student still.
Almost there.
Almost there.
Almost there. So Paula, if you could introduce yourself and tell us a little bit more. We are excited to learn about wind scour.
Yeah, so I'm Paula Sarmiento. I'm from Ecuador, and I'm here doing my PhD in NC State. I work with Dr. Luis Zambrano Cruzati, and well, our work is wind scour, wind erosion, and also some modeling in flow transport in partially saturated media. Mm-hmm.
Cool. And did you come to NC State with the quest for wind scour, or were you gifted this project to do?
So originally, I started my program in UMaine with this project, and then life happens and we end up here. But I'm very excited. Like, I'm very grateful in my experience at UMaine, but I'm also very happy to be here in NC State. That is such a great state. Yeah.
Yeah, it's exciting. Well, do you want to tell us a little bit about what do you mean when you say wind scour? Or I think do you have slides you want to share, or how do you want to hop in? Let's hop in.
Yeah. Okay.
Perfect.
Okay, let me know. Yeah, great. So today I would like to talk about broader physics of transient moisture and wind-driven erosion in coastal dune systems. I know that in the previous episodes on our Scour, you have covered scours in a lot of contexts like bridges, rivers, offshore foundations, but today I want to take the conversation into a bit a new terrain. So this is specifically for wind erosion coastal dunes. So I want to share how we transition from a water-driven, fully saturated process to a wind-driven one. This is our fluid in this case. And as you can see from the contrast of this slide, while the hydraulic scour is in the immediate force during extreme events, wind erosion is the chronic worker that reshapes and rebuilds the dunes afterward. So let's think about why do we care about studying dunes. So coastal dunes are a critical line of defense for shoreline communities. They dissipate wave energy, they reduce storm surge impact, preventing inland flooding, but these structures are not static. So after storms erode them, wind gradually reshapes and rebuilds them through aeolian transport. So understanding this wind-driven process is essential because it governs how quickly and effectively dunes recover after extreme events. So to put this in perspective, I want to share a little bit what happens in our state, North Carolina, which is a classic example is the Outer Banks, which is a highly dynamic barrier island system. Historical data from agencies like the NOAA and the USGS show that due to its position jutting out into the Atlantic, the region is exposed to high energy conditions year-round, from hurricanes to winter nor'easters. So the frontal dunes act as a primary buffer for these islands. To show that a little bit more how it plays, let's take a look of this case study from the USGS at Kitty Hawk that is in the Outer Banks. In the left photo from February 2016, we see a system that is protecting the road that is in there. And in the next photo, after the Hurricane Matthew, the protective dune volume has completely disappeared, leaving the asphalt directly exposed to wave attack and undercurrent. Once the storm recedes, the highway only becomes safe again if the wind can move enough sediment to rebuild the dune in the time. Now, coastal engineering has long studied how dunes evolve at the system scale, how much sediment moves, where it goes, how the shoreline shifts over the years. But as a geotechnical engineer, how we can contribute is to look at the grain scale physics. And then we can understand why and when the sand actually starts to move at the surface. So I will talk about a little bit how these physics work. First, understanding that wind-driven erosion begins when the wind shear stress at the surface exceeds the resistance of the material. We quantify the wind forcing through the friction velocity U star, which combine both viscous and turbulent shear components. When this friction velocity exceeds what we call the friction threshold velocity, or FTV, sediment entrainment begins and sand particles starts to move. Now, a key parameter that plays in this type of conditions as the coastal dunes is the water content. This parameter controls the threshold where, as in partially saturated sands, water forms capillary bridges between grains, increasing their cohesion, therefore a higher friction velocity to erode. But there is an also important point here. In these conditions, in real field conditions, this water content is not steady. It changes continuously over time. So I like to use this diagram to show all the events that contribute to these changes. As you can see in this schematic, several processes drive water content change. Rainfalls and droughts alters infiltration, tides raise and lower the groundwater table, and solar radiation drives evaporation from the surface. This process operates across different timescales as well, from hours to season, and they continuously, again, alter the FTV. So in this case, what we know so far, first, we started from the foundational model that comes from banknote for coarser material to understand what is this friction velocity, which tells us that the FTV is essentially a function of how heavy the particle is. And more recently, our research group extended this by incorporating a moisture factor using the saltwater retention curve. However, this model was developed under steady water conditions and does not account for the transient change that we just described. And this is the exact gap that in this part of the research has motivated us to understand how transient moisture affects the FTV. In particular, in our research, we tried to do some experiments. So just as a first step, we translated the complex dune system into a controlled one-dimensional salt column inside a wind tunnel. We started with this simple setup to understand and monitor the parameters as the ambient parameters, moisture content, and also to detect and measure the friction velocity. Just to add a little bit about my work, we did some experiments at the Neri bundle layer wind tunnel at the University of Florida, which was a great experience, such a cool setup, very intimidating to be in that such wind tunnel. And in this one, as you can see, we tried to do that 1D scale to monitor the parameters that I show you. And just to put it briefly, what we saw in those experiments were two behaviors: intermittent erosion, and also that it is very difficult to measure this upper layer that controls the erosion. So this is a schematic that we have that what is happening here, and that's why it's so complex. And it's very important, our insight as a geotechnical engineer. Erosion will start at lower wind speeds than the steady moisture model predicted, the current models that we have in hand. And when it started, it didn't come continuously. It came in bursts to our working hypothesis. And this is an hypothesis because we're still working on. The picture is that sand grains held together by water bridges. Evaporation happens faster at the top, so the surface bridge breaks first. The wind takes those top grains, exposing the water layers underneath. The layer resists for a while, then it dries, and the cycle repeats. So under transient moisture, erosion is cyclic, driven by surface drying. And this ultimately highlights a complex interplay between atmospheric demand, fluid rotation, and wind mechanics. And this is, again, our perspective as geotechnical engineer adds immense value by analyzing coastal erosion at an intergranular level, focusing on microscale capillary dynamics. We can help refine the inputs that macroscale coastal models rely on, bridging both disciplines to better understand the material itself. So this is what I had to present to show you a little bit about my work and also to help you introduce how our input is so important in this. And I'm happy to take any questions from this.
Cool. I think, I mean, you can keep your slides up or we can go big. I don't know. What do you want to do, Brad? Do you want to go big or go small?
We can go big for now. If we need to go back to the slides, it's easy enough. And so that is an important thing. When you have questions for Paula, please put them in the chat box immediately to the right of where you're watching this video today. And we will get to them, we promise. So Stacy, that's back over to you and you get to lead off.
Oh, you said something interesting that I had never thought about. No, you didn't say it. It was a diagram that I had never thought about. You had the groundwater table and then the unsaturated zone. Does that mean dunes are only made of unsaturated soils and the groundwater table is like what you treat as the ground surface?
Well, actually, just recently, I think the first setup of sensors we did was like 2 months ago. The last week we also did put some sensors in an actual dune system. And what we have been observing is that, well, it depends of the material, how high will be the capillarity. So what we have seen, there is some influence until some distance, and then at the upper layers, there are not influencing these changes of the water level of the sea, I guess.
So that was just based on your setup, not necessarily a definition of a dune. Dune definition? Dune, yeah.
Yeah.
Interesting.
So I think anybody who lives on the East Coast will see from time to time these news reports. For us up here, it's the Delaware beaches, it's Ocean City, Maryland, etc. And every February, there'll be the news story about the trucks coming in with all the sand and getting the beach ready for the summer season, and on and on and on. And then sometimes, if it's a really good news station, maybe they'll do a piece at some point before summer starts about coastal erosion and about some of the problems that this beach management can cause. So it's going to go a different direction than you think it's going to go. I know you guys did most of your work there in the Outer Banks, but I guess how much variation do you think we can expect to see on the eastern seaboard in wind erosion? Because it's not even, I guess, is the best way to say it. What you're going to see in Florida is a little different than what you're going to see in Maine. What variation have you guys seen?
In the Outer Banks? Well, so I just exposed the Outer Banks as a common case as in the states that I am. The sensors that we set up right now are in Masonboro Island, Wilmington. And currently we're still processing the data, so because it has been recently, 2 months. So I think we still have time to see those changes and to analyze it. This will be a very cool project because in that area that we install those sensors, we also are with the help of the Coastal Engineer Department of NC State, we are monitor the changes of the morphology of the dune. So that's something that is coming.
It's a future research question, Brad. Not there yet.
Not there yet.
Thank you for your thought. That's how you respond. It's an interesting thought. We're not there yet, but we will be. I have a similar, in Texas, but I think everywhere, I'm well traveled. When we go to the beach, like driving down the little road next to the beach, and before you like cut through the dunes to go and then drive on the beach and park and pick your spot. I don't know if they do that in other states. In Texas, you definitely drive where you go. When my mom was growing up in Corpus, she said they used to roll VW bugs down the dunes. I don't think you're allowed to do that anymore. I don't think it was a good idea at the time, but that's what happened in the 70s. Anyway, it's kind of hard to see sometimes because of all of the grasses that we have growing on top of the dune. So how do the native grasses change your hypothesis or do you account for that? Or that's not a question. It's just a thought framed as a question.
In our research right now, we're trying to go into layers. So right now we're assuming that there is no vegetation, but for sure the vegetation will add some other layer of change in this situation because vegetation creates more cohesion to the surface. But for now, because it's kind of a recent topic for us in the sense of that not many people has looked at this from the geotechnical perspective, we're trying to go by layers. And at this point, we're at the transient moisture condition.
I feel like we're just going to ask you 800 questions about research that's coming or that could be coming, right? Because I have a similar thought about development, right? When you look at a coastal area like New Jersey, where it's very rare to have an undeveloped beach, and there aren't a lot of dunes, or they're much smaller than they are when you get into the South Atlantic part of the country. I mean, do you guys have any plans to look at how development influences this? There are coastal houses in North Carolina. One just fell into the ocean the other day, and I saw that on my local newscast.
Well, so honestly, what we expect or to help our grain into this part of the research is to improve the models that currently are to that models the changes in the morphology of the coastal dunes. Because understanding this parameter to know how, in what moment will we start the erosion will put a very good input that just saying, okay, in this area we have a constant water content and then it will develop like this. So that's our input. That's some of our objectives in this project.
Have you considered a citizen science effort where people start to build gauges on dune erosion efforts based on how gritty their eyeballs feel?
What do you mean by
It could be
that?
a meter, right? We have a high transport today. Everyone must wear sunglasses. No, okay.
But I do think, so Paula, you've figured out by now, our Scour is just us saying stuff, and it becomes much more conversational as we go through. But this would be a really interesting area for a large-scale citizen science project. I mean, you look at the way it's worked with Did You Feel It, for example, the USGS citizen science seismic system, I guess. This could be really, people are deeply concerned about the health of beaches, especially on the East Coast. That's a really good idea.
Thank you.
This is
Our
what we
Scour
all
is now
need to go to
turned in-
USGS and tell them to start this up.
Assistant professors, take notes. This one. Next proposal. Or for your future career, Paula. It's good to write down your ideas as you're going, where you want to grow, where you want to take it. That could be, though, something. Don't do it with children. Part of citizen science sometimes is K through 12. I don't suggest K through 12 on the eyeball meter. That's no good. The number of waivers you'd have to sign, probably not a win.
Permanent damage. Yeah.
Just children crying, eye drops everywhere. If you ever put an eye drop in a child anyway, that's its own feral experience. If they've ever gotten pink eye, 17 drops to get the one in the eyeball.
So I know a lot of your work has been modeling to this point, but can you talk about any lab facilities that you've used in this work? I mean, coastal lab facilities are awesome. Like if anybody's ever been to Corvallis and you see the wave tank, you see the flume, that is like for nerds, that's a once in a lifetime opportunity. What facilities have you guys utilized so far?
Well, for now, it has been only the Neri wind tunnel boundary layer that is in Florida, Gainesville at University of Florida. That is such a big installation. Like I remember the first time that we went there, it was like a thing that you have to do when you get there. You will be at the wind tunnel and then we'll start the fans and just to feel it right on you at the back. Yeah, it's such a cool experience. The people there, they're amazing. They really help a lot in this project. Last year, I did some experimental work that I still have to work on. That is to recreate a scale dune. And and it was such a hard work to build in that dune all over again. And the test will last, I think, at most 30 minutes, and then it will be blown away. So again, for all that time building that dune, and it was a cool experience, very hard work. So I have a lot of respect that people or researchers start doing scale experiments, honestly, because also what I did, it was hard, but it's not as big as some others that I have seen, those flumes that they use wave breaking. That's a lot of work.
Very cool. But that's again my pitch. Get out. I mean, go visit Nina Stark in Gainesville and you can see her cool stuff too. But Corvallis will blow your mind.
Yeah. When we were there, we saw Nina. She's very cool. And I really, for me, she's a star.
She's
another
a star
Geo-Palooza pitch.
Yeah.
She was included in Geo-Palooza. She did an episode of Field Trips from the ship that we posted last Tuesday. So everybody needs to go check that out.
Also, she was episode 2
of our Scour, correct. You can go back and check that out. And we asked her all kinds of hard-hitting questions like,
what's the weirdest thing you found in a scour hole? Stingray? Do we have we generated?
We have no questions from the audience yet. That means that everybody gets more of me and Stacy.
Excellent. I mean, who doesn't want more Brad and Stacy in their lives?
But again, if you've got a question, pop it in the chat and we will get to it.
So how, you've said a couple times, I mentioned my faux pas in the beginning, that your PhD, not yet candidate, but soon. So how long have you been working on this, and you never asked PhD students how long to go, but how much time have you put in?
This is a hard question for any PhD student.
Yeah.
So I just finished my second year, and hopefully this year I will do my qualifiers, and then next year I will do my prelim. So I'm thinking that hopefully I might be over in 2 years, but those are the expectations. But still, I'm very glad that I'm still able to take in all these courses that NC State has given. Like, there's such good professors like Dr. Gabbard, Dr. Montoya, Dr. Cabas. They're really cool people and very good professors.
Yeah, definitely.
Mm-hmm.
Is like your experimental campaign complete, or do you think you'll do more work, or was that like a phase?
Well, right now, I think I have to only work with the data that I have from the previous lab experiments that we did, but because we just installed these sensors in a real dune, probably that we will collect the data for a year and then we work on that too. And we are very excited about that, actually.
Is your ideal world, you never want to wish for a hurricane, but is your ideal world a hurricane for data, or are you hoping for more non-extreme weather processes? There's a word for that. I don't know. It left me.
What I think for that? Okay, I think for now we are really interested how with the different seawater level is changing and influence the groundwater level, and then with the detection of the change of the dunes, we will see how it goes.
So just normal day-to-day, not extreme.
Normal day,
nothing extreme.
Nothing extreme for this case, yeah.
Even Hurricane Matthew, if we can talk about that for a minute, since you showed that slide, was not actually one of the worst hurricanes that we've had in the Southeast, but it was interesting because the path it took, everybody can bust out a map and look at how the Southeast U.S. is shaped. The coastline goes in like this. And right on the inside of that crescent is the Georgia and the South Carolina coast. Matthew impacted that region more than I think any hurricane ever had, maybe in recorded history, or certainly in 75 years, right? So what specifically about Matthew have you learned in this work that you said, wow, this is a little bit of a different storm than what we would usually see here? And as a result, X happened and it was different.
For me, it was more about how these extreme events are just a single event that will change the morphology. So that really impacts how the coast is shaped. But then this silent work of wind erosion that will rebuild again, if not artificial dunes. But that's something that I'm very captured about, that how this single fast event happens and then the long, steady work has to happen to rebuild these dunes that are so relevant for protect the inland.
And I think it's hard I don't know if you've had to explain your work to, I don't want to say average citizens yet, but lay people. How about that? That's the term we're supposed to use. But I think it's really challenging to explain work like this. You get a storm. In the 90s, we had one out here called Hurricane Felix. It was massive. It was a Category 5, and it was essentially going to be a direct hit between maybe Morehead City, which on your map, that was the little pointy part, near the little pointy part, the barrier islands of North Carolina, and Virginia Beach. And it stalled. It never came ashore. Massive amounts of wind damage, massive amounts of beach erosion from the waves that came in. But I think it's very hard for people to understand that without the storm actually coming ashore, that it can do that level of damage. What sort of community outreach have you had to do as part of your research, or has it been nothing yet?
So I think nothing yet, but just to make things like lighter, I try to explain to my mom and my friends that are not engineers. So that's something that I try to not lose myself in the details because that's too easy to go. But yeah, it's kind of a difficult word. For example, my mom, she's a doctor in medicine, so she doesn't understand. Well, for her, it's hard to understand these things. But she always pays me attention, and I'm trying to do my best. And with her, it's such a good practice to do, and that helps me to reach out to more people about these things. Mm-hmm.
So one more, and then I'll stop stealing the spotlight here, Stacy. You grew up in Ecuador. For anybody who doesn't know much about South America or doesn't know this, you guys don't have tropical cyclones on that side of the continent. I mean, what has been the most interesting part for you for getting involved in this work that does need more extreme events for more extreme change?
Yeah, for sure. Like, I think living in my country is more about earthquakes. Like, that's the main hazard that we have, but never about tornadoes, hurricanes. So when I came here, that's like I wasn't familiar of hurricane season, that every year will happen and every year you have to prepare yourself for that. And I think that's something that makes me think very like a very curious child in this perspective. Like this all of this is new, so I have the opportunity to ask all the questions about it. Like
Yeah.
I didn't know that. Yeah.
But I was pseudo paying attention, and that you said right now the hurricanes may happen, but you're focused on, I'm just going to call it transient weather. This is what I feel like the term is. I don't think that's right. But non-hurricane weather. But do they, pardon my ignorance, have dunes in Ecuador where this would still be relevant along the coast, even though or are dunes primarily for hurricane?
I think dunes in
Support.
Ecuador are pretty much smaller than the ones that are present here in North Carolina. I remember one time looking at this map in the world map of the presence of dunes. We don't have too much presence, and then I look a little bit more deeper, and it's not that higher, but still, it might be. Maybe I'm just putting it out there. I'm not know factually. It might be helpful to understand it in all places because the seawater level rise. So.
Yeah, so this is kind of, I'm now morphing my thing into a question. So I always assumed that the dunes were just naturally formed barriers, right? But again, I grew up in an area where we have dunes everywhere. But I have been to beaches in other parts of the world that don't have dunes, I think. Obviously, maybe. So are they there? Were they naturally formed then, you think, from maybe it's a better way. Do you think they were naturally formed from these extreme events over time where like it piled up and then it became the system, or how or why? Here comes Brad. What do you World dune map. See, so there's many coasts here that don't have dunes. For reference, I lived in the Middle East, and so not a lot of dunes over there. I lived in Turkey. I'm trying to find it. It's kind of hard when I need the blue.
No dunes.
Yeah, I need the blue. But I found it. Yeah, no dunes. And so I had been to many duneless beaches. I never thought about it because I was a child. But yeah, where do they come from?
So
why do you have 37 tabs open? Oh my gosh, we got to focus, but you're one of those. There's two types of people. Okay, sorry, back to dunes.
Yeah, so in my country, as you can see in the picture, right in the bottom is Peru, where they have dunes, but in the upper part, that is my country, we don't see common dunes. Like I have seen brief works that they tell like something about 30 centimeters, like very low. It's just
Wow.
yeah, like there's not much presence in my country. So that's why also being here at the beaches here is a very cool landscape to watch as well.
Yeah, very different.
Mm-hmm.
See, this was a highlight. I've been to many California beaches. I had never thought about it, but there was no red on your little California zone.
Yeah, it's completely different, right? Like I was just
Yeah.
out there a few weeks ago. Like you just walk out, the topography is completely flat. Like you might get a cliff here and there. I was surprised. I was in Irvine and there were cliffs at some of the beaches, and that was the first time I had seen that in Southern California. Very, very different from the Southeast US, I think. So I want to ask about applications for work inland. And the thing that I thought of immediately when we were going to do an episode about wind erosion, wind scour, was the wind farms, especially the large ones that are out in like Southern California, the solar farms that are also in that part of the country. And they have incredibly high winds in that part of the country as well. And so that is what made me think of this. What applications do you see for your research for more inland stuff? It doesn't have to be the wind farms or the solar farms, but those would be two good examples, I think.
I will have to think about more deeply. Like I think until now I have been stuck coastal dunes, water, beaches, sand. And so I think that's a really good question. I think it's something that I will need to think about because as I told you right now is about sand. And I think in those applications that can be other materials as well. So for now,
Ooh,
I
we
think
have our first question from the audience.
you prep up the question. I'm just going to dovetail on yours. But I think back in the day when I was a PhD student, my friend at Arizona State, Nasser, looked at wind erosion in Arizona in those near surface sands. And so I think that they've looked at a lot of stabilization processes, but there may be some more to dovetail off into that adjacent direction. Sorry, now I can name drop, so I had to say it. Okay, ask your question.
Shout out Nasser Hum.
Yeah.
Well done.
Yeah.
So here's our question from the audience. Have you, it's two really, but it's one thought, I guess. Have you looked into how the shape of a dune impacts the rate of scour? For example, do certain dune geometries generally have different heights of capillary zones?
That's a very good technical question. Why didn't we think of that, Brad?
yeah, so that's why we did those experiments with the scale dune, just to also understand how the flow dynamics change around the surface of the dune, because of course the wind will affect the sediment transport, and also the height of the dune will affect how the wind flow will behave. So that's something that we are looking forward to analyze with those experiments. Mm-hmm.
This is work that by its very nature, I mean, you talked about going to the wind tunnel in Florida, and you talked about sediment transport and a few other things throughout the interview. This is just interdisciplinary because it is. I mean, what's the wildest character you've come across yet? I mean, because you must have had to come across people from the aerospace department and not even environmental engineering. Like I would see, this is probably geology colleagues and stuff like that. What other departments have you been working with, and what's that work been like?
So, well, I have been working with people with coastal engineer, but also engineers, specifically in that wind tunnel facility. There were such incredible engineers. I think for me at that moment that I just came because also when I came here to do my PhD directly, I went to do experimental work. That was an interesting experience. But I met this Dr. Catarelli. He's a civil engineer, but he is specialized in fluid dynamics. And he's amazing. And I remember last year when we were doing this scale dune experiment, he loves Dune, the movie Dune. So he has this very scale Lego, and we took some photo shoots of that. It was fun because that work was very heavy and like stressful, and having that little moment, and also seeing other researchers being themselves, that's also encouraging, I think, for everyone to see that.
And that's a good thing to add here. If anybody's looking for that Dune world map that I put up, you're going to have to add words to the Google query because otherwise you're just getting all kinds of results related to
Yeah.
the
The
book
movie.
and the movie Dune,
Yeah.
which was not what I was looking for. So you brought up CFD. I mean, as you have gone through this project, your fluid dynamics are going to be different than any of the other, and when you're working with solid materials, right? What have you learned from CFD that was a valuable lesson as you've gone through this?
So for now, what I have been get into it is about turbulence. Analyzing turbulence data like instantaneous and the variance. I think that has been a whole new world for me when I came here, and also understanding how complex it is making you think, okay, I don't know anything and I have to start building this. But it's a very interesting perspective of analyzing the statistical part of the random data. And I haven't worked in actual CFD models yet, but what I had to process all this data to get the friction, the FTV, that was such an interesting part to learn, the turbulence and the instantaneous data and how the statistics of it tell us about specifically in this fluid dynamics part, the shear resistance of the flow among the surface of the sun.
So have you looked into or collaborated any with like aerospace engineers? Or I see you say turbulence. I'm just thinking like, has your thought to air travel changed now? Based
No,
on
no, I haven't collaborated with anyone of aerospace engineer, but that will be such a cool experience. I think when I got this, like, because I had to take classes, of course, to understand and learn about in papers. I think that is such a difficult part, but I'm very into it right now. Like whenever I see something, I'm trying to analyze the energy curve, the frequency data about this random data. So yeah, I haven't worked with them, but that's something that I'm curious about as well.
I think we're about to dovetail into that because we're having a fluid scour problem, but it's with a complex geometry, and so it is kind of turbulent. And now things how we've normally set up our model doesn't work. And so my colleague was like, "I know an aerospace engineer that handles this type of things around wings," and I was like, "Cool, ask that guy," because I have no idea. All I know is this is not right.
Yeah. Yeah.
So I'm going to make one more call to the audience for questions. If you've got anything for Paula, just put it in that chat right there as we start to wind down. You want to make sure you get your questions in. That's what makes these rich and vibrant. Those are the two words I like to use. And so you got to get a nostalgia question here. And you have to think back, Paula, to the beginning of your undergrad. Maybe that's far enough back. Did you think you'd be doing this work now? And if so, how did you decide you wanted to do this? And if not, what convinced you that this was worthy research to do?
So I think when I was an undergrad, I wasn't expecting anything of this for sure. Like, I think when you're undergrad, fluid mechanics, hydraulics gets a little bit intimidating to work with, and in this research, because you're working with wind flow.
Even if you're 46 and you're the director of the Geo-Institute, it might be a little intimidating. Just saying.
For sure. So when I came here, we had to do a lot of work of also using sensors, set up the codes to the sensors to work along in the experiments, and getting into more deeper about fluid mechanics. I was, of course, intimidated, but I'm happy that I got into it because at least that fear went away a little bit. And I think part of me being very grateful of being part of this project is being able to also discovered this other part of civil engineering that is coastal engineering. And I think I have to admit that they have the coolest part of doing experimental work because they go to the beach. Like last time, when we went to set those sensors, we had to get to this island with a jet ski. So
Yeah.
I think that's pretty cool stuff to do, like daily part of your research, like that's part of your work. And I think I'm very grateful of that, and also, of course, learning about it.
I will say that's totally true. And I got to go out and we were like on a boat and it was beautiful weather. And like we had like a little bimini up for a little bit of shade and some water. And we're just coasting around collecting data. Life was good. And then the next time my students went out, 3 of them threw up overboard and like it was apparently miserable death weather with like horizontal winds. And I was like, oh, well, I'm a fair weather coastal researcher for sure. So there can be bads, but going out on a jet ski, man, that sounds awesome.
Yeah, it was awesome.
So in undergrad, did you like geotech or were you general civil?
So I was general civil, and I think in my country we're very focused, or the college are very focused to teach us about seismic engineering because of our region. But I still remember when I took the geotech class was very capturing because geotech is a field that there is a lot of uncertainty because of the material that we're working on, and I think that that's very challenging and interesting. And then when I was taking my first internship, I went to a geotech consultancy, and then I wanted to stick there. And I tried to take my path on there, and happily I got to be here.
That's awesome. It's kind of funny how, like you're doing all this work and, you said when you were an undergrad that fluid mechanics was maybe a little bit scary. And I felt the same way. And I did not like fluids and I didn't like electricity, my double E classes. And all of my research is in scour and erosion and applied geophysics with electromagnetic methods. And I'm like, I think I just like doing hard things. Like, why didn't I go into structural engineering? That was much more straightforward to me, but whatever. You go where you go, and you have regrets of where you possibly didn't listen as much, and then relearn it, right? This is the charm of grad school.
So we didn't have any other questions come in from the audience. Stacy, I don't know if you have any others you want to get to before we wrap up, or should we give Paula some last words? If you've got anything you want to say to the people of GI, as we say, or a pitch for your research where people can find it, maybe your group's website, et cetera, et cetera.
Yeah, for sure. I think I want to say that I'm very thankful for being here to have this opportunity to talk with you, Brad and Stacy. It has been such a fun time, actually. I was very scared, but you're delightful people, honestly. And I think, yeah, actually, yeah. And maybe I want to give a shout out to our research group that we have a website and you can find it as CGEM is ZG. Sorry, because it's always tricky with the Spanish with the I and the EM. So I will write it here just to. And if you look for it, and at NC State, it's easy to find. And there is our group, my professor, my other peers, and also a little bit about the work that we have been doing all this time.
ZGEM at NC State. Go check it out, people. Go learn more.
And we can put a link to that in the notes below where you're watching this right now.
Yeah.
That was awesome. Paula, thank you for being here with us today and telling us about your research and learning us some stuff about wind scour. I love that. That was really good. For all of our viewers, if you liked what you saw and you're here at the end, so you probably did, again, click like, subscribe, and get notifications. And yes, we let you know every time we post something to the YouTube channel. Our next live stream is in just 48 hours. You're going to want to be back here. It's part 2 of GeoPeers 2026 live series with the Geo-Institute. Steve Whirling from GeoPeer will be here to talk about sustainability and brownfield sites. You're not going to want to miss that one. We also have, 3 more days left of Geopalooza 2026. So there's going to be more content coming your way. Another great director's cut tomorrow. The final Geo Pit from Geo-Congress 2026 on Friday. More photos. We might have some special bonuses in there too. And then right from there, we transition without even batting an eyelash into the Geo-Institute Summer of Live. And we will get to that starting on Tuesday with Carlos Santamarina's first live streamed Cross USA lecture of 2026. That one, I believe, is a rock mechanics lecture. Let me check real quick. Yes, it is. You can register for that and all of our other live streams on our Eventbrite page for free. That means no money will change hands, just your emotions and your brain power. That's all we ask of you. Paula, thank you so much again for doing this. I'm glad you said it was fun already, so I'm glad it was a good time.
Yeah, we will.
Stacy, wonderful job hosting as always. And we'll be back next quarter with another hour for Scour. I'm just going to keep saying it, and you'll have to keep coming back, and we'll keep booking guests, and it'll be amazing.
Great. Looking forward to it.
Guarantee it. Our producer today was Aurora Flieger. We will see everybody very soon with another Geo-Institute live stream.